going to start with section 7.3, and in review, our attempt here in the next couple sections is to be able to solve any quadratic equation. We've already learned a couple techniques for solving quadratic equations, for instance factoring and using the zero factor property, and also we've learned how to use the calculator to find zeros with our zero command. We're going to learn a few more algebraic techniques, but before we do that we need to revisit one of the techniques that we learned earlier in the class, and that's how to simplify square roots, because some of the equations that we solve when we solve quadratic equations wind up with square root answers, and we need to make sure we remember how to simplify. So with that said, if you turn to your book, page 368, we're going to revisit our process for simplifying square roots, and we'll start with number 1. And when we simplify any square root, we first need to decide, is it a perfect square? And if you use your calculator, if you don't know in your head, you can use your calculator and you can see that square root of 169 is in fact 13. So probably the most simple type is when we do have a perfect square, and there's really not much work to be done. We just evaluate it and we move on to the next problem. If you look, however, at number 3, where we have something like the square root of 12, that is not, and again, you may know that without having to use a calculator, but ultimately that's not a perfect square. So therefore we need to simplify this if possible. And the method that I showed you in the past was to use the box technique, where we put 12 in the box and then we divide it by the smallest prime numbers possible, 2 being the smallest prime number. And since this can be divided by 2, we'll divide it by 2, put the result here at 6. And then we'll continue to divide until we get down to a prime number on the bottom. We can divide by 2 again and get 3. Now, we know we're done here because the 3 is prime, and that is the end of the process. And then to simplify, we look to see on the outside here, both bottom and left-hand side, do we have any pairs? And in this case, we do have a pair of 2's, so that pair comes out as a 2. And so our final answer is 2, and the 3 cannot come out because it's not paired, and so therefore we get 2 radical 3 as our final answer. And what's nice is we can check that and make sure we did it right by taking 2 and multiplying it by radical 3 and showing that that's exactly the same as what we get if we did radical 12. And just a couple others just to review. Look at number 7, same page, we have square root of 6 over 49. One of our square root properties is that we can change the division into a division of the top and division of the bottom, and then handle these separately. If we do radical 6, if we try to put 6 in a box and we divide it, we don't have any pairs, so that does not reduce at all. But the square root of 49, of course, is 7. So when we get finished, we're at the square root of 6 on top, 7 on the bottom, and we're good to go there. On number 9, when we have 5 radical 2 is prime, so that does not come out, but there's one other technique in dealing with square roots that we need to remember, and that's the fact that we can't leave the square root on the bottom. So to remedy that, we multiply by square root of 2 over square root of 2, which is ultimately 1, which means it doesn't change the value at all. It just makes it so that we have 5 radical 2 on the top, and then on the bottom, radical 2 times radical 2 is radical 4, which ultimately becomes simply 2. And so we've done what we call rationalizing the denominator. We've gotten rid of the radical on the bottom, and we've gotten a final answer that doesn't have a radical on the bottom, which is the appropriate answer in any square root problem, is to not have a radical on the bottom. So with that, there's lots of practice problems in here to practice the box technique and so on. And so I would suggest that you do that, of course. But one of the reasons why we need to be able to solve square roots is because one of our types of quadratic equations is x squared equals 25, like in number 17. And ultimately, if we're going to solve this type of equation, and you have this in your notes too, I gave you a sheet that has the information regarding solving different types of quadratic equations. And the type that has just a ax and a c, no b term if you will, there's no bx term here. The general strategy it tells you in your notes is to get the x squared alone, which we clearly have in this case, and then take the square root. And if we take the square root, we get square root of 25 over here, and that would ultimately be 5, because 25 is a perfect square. And the other thing that needs to happen is we're going to make sure we put plus or minus on our answer, because both 5 squared is 25 and negative 5 squared is 25, and we get our 2 answers here. Okay. And if we look at another example of that, say number 25 for instance, we have 3p squared minus 11 equals 3. And again, you'll notice there's no p term here, so our general strategy is to get the p squared alone. So if we add our 11 to both sides, we get 3p squared equals 14. And if we divide by 3, we get 14 over 3. And if we take the square root, we get plus and minus the square root of 14 over 3. And remember, ultimately, if we tried 14 in the box, we'd get 2 and 7, which means that doesn't reduce at all. But if we rewrote this as radical 14 over radical 3, back to our original problem up here, we don't want to have a radical on the bottom, so we'd multiply by radical 3 over radical 3. And we'd ultimately get on top radical 42, and on the bottom we'd get 3. And just for argument's sake, we should check, keep in mind that's plus and minus also, check that 42 just to make sure that can't be reduced. If we do 2 and 21, 3 and 7, you'll notice that again there are no pairs, so radical 42 is simplified and we get our final answer. Now, if you would go with me to your practice quiz, or practice test I should say, and look at number 21. We have another equation similar to the one we just dealt with. It looks like this. It's got that no bx term, so therefore our strategy is to get the x squared alone. And if we do so, we get x squared equals 7. And if we take the square root of both sides, we get our two final answers, which are plus and minus radical 7. And again, you have notes here that you can use on your quiz and test, and it says right in there to make sure that you don't forget to put plus and minus on the result. So make sure you follow your notes carefully so that you don't just give half the answer, which most people, if they do it wrong, they put positive radical 7 and don't put the minus answer, which needs to be there. Okay. So with that, that's again our general strategy for solving a quadratic equation that has no bx term in it. And there's another thing that happens with quadratic equations is that what it boils down to is that all quadratic equations can be solved, but they don't always have real answers. And if you think about it from what we did last time, if we were to graph a parabola such as, let's say, x squared plus 2x plus 4, and we draw the graph of it. Let me change my window to a standard window here and see what we see. You notice that in this particular example, again, remember the solutions to the quadratic equations are the x-intercepts. And if it doesn't have any x-intercepts, then are there solutions? And the answer ultimately to that is yes. However, the solutions are not real solutions. They're not real numbers. They're what we call imaginary numbers. And that's what we're going to take a look at next, because some quadratic equations, when we solve them, we're going to get imaginary solutions. Okay? So to start out our discussion of imaginary numbers, let's first take a look at on your page 369. We're looking at number 49. What happens if we have a negative under the square root? Because that's what's ultimately going to happen when we have imaginary solutions, is we're going to get negatives under the square root. We know that from our past experience, if we try to take the square root of a negative, it gives us an error. It says non-real answer because it is a non-real answer. So in the past, we might have just said not real and said there's no solution, but from here on out, when we have a quadratic equation, we wind up with a negative under the square root, then we need to be able to deal with this. So what it boils down to is we're going to use one of our other properties of square roots that allows us to separate the negative 36, that is, into negative 1 and 36. And ultimately, we know that the square root of 36 part is 6. And then this part right here is defined as the square root of negative 1 is equal to I. And I is just what we call imaginary number. Okay? So this part would be I, this part would be 6, and we generally write I as a variable, so we put it behind the 6, and so our final answer to that question would be simply 6I. So anytime we see a negative under the square root, we're going to find that we're going to have an I involved. And with that said, if we look at just a couple more examples, we have some in our arsenal here. We have a negative square root of negative 45, and so if I want to simplify this, I recognize that I have a negative 1 and a 45. Still got a negative out in front, keep in mind. We know that this becomes I, negative still here. 45 might be the final answer, but if we put it in a box, we're going to get, can't divide it by 2, but we can divide it by 3 this time. We get 15. We can divide that by 3 and get 5, and we do in fact have a pair. And so we'd have 3 radical 5 would be the simplification of radical 45. And again, that can be checked on the calculator. And then so the ultimate answer here is to put the I behind the 3, so we get negative 3I. Radical 5 would be the from that group. If you look at number 53, we got negative 5 over 49. If we wind up with a fraction under there, we're going to handle it the same way that we did previous, except for we're going to take that negative 1 out of there first. And that's, of course, going to become our I. And then we'll separate the top and the bottom, 5 and the 49. And we're ultimately going to end up with I radical 5 on the top, 7 on the bottom. And that'll do it. Now, if you would, just go ahead and find on your practice test number 6. We have another one there that is just involving simplifying a square root with a negative underneath. And of course, at this point, we know that our strategy is to separate the negative 1 and the other number, 75 in this case. And we know that radical negative 1 becomes I, the 75. If we put it in a box, we can divide that by 3 and get 25. Can't divide that by 3, we can divide it by 5. 5. We do have a pair of 5s, so that means 5 radical 3 would be our result there. And so final answer there would be 5I radical 3. And since it's multiple choice, you can see that the answer is letter B. And that would do it. So the general strategy is very much similar to dealing with a positive number underneath the square root, but ultimately we have that E situation to deal with. Okay? Now, here's where that comes into play in terms of solving a quadratic equation, and that's if we have something like, say, number 22 on your practice test. So, practice test number 22, and we have 25x squared plus 16 equals 0. And ultimately our goal here, since there's no bx term, is to get the x squared alone like we did in the previous problems. And when we get to this problem, you'll notice that the difference is we have a negative on the right. And so when we take the square root, we have a negative under the square root. However, if we take the 2 on top, negative 1 and positive 16, and then 25 on the bottom, and separate the 3 parts, if you will, then we can simply get I here for this part. Square root of 16 is 4, square root of 25 is 5, and so we get 4I over 5 would be our final answer. And with that, we got one more thing to remember. We're taking the square root in the equation. We need to give both answers, so positive and negative version, and so therefore we get plus and minus 4I over 5, and that would do it. Now, so ultimately, again, the gist of this section 7.3 is to be able to deal with square roots, both positives and negatives. The fact that when we have a negative square root, that gives us an imaginary number, I, gives us imaginary solutions. When we simplify the square roots, we're going to still use the same techniques that we did in terms of the box. And then also when we solve an equation, and the gist of the equation solving part of this section was the fact that we have equations of the form ax squared plus c equals 0, which means that there's no bx term. And if that's the case, then we follow the general strategy of what we did here, which is get the x squared alone first, and then take the square root of both sides, simplify the square root, and make sure that we have plus and minus on our answers. So that is it for section 7.3.